say x, 3 minus x, x plus 4, everything divided by x minus 7. You want it greater than, less than, what do you want? Thank you for coming. Thank you for coming. We just started. We didn't do anything. Thank you. You want it greater than or less than? Very good. Okay. Oh, just greater than or without the equal symbol?
Yeah, you're right.
Okay, that's fine. Good. So first of all, because it's factored already, I can go ahead and use the table. If it's not factored, then I have to factor it on my own. But it is factored, right? How many factors we see in this problem? One, 2, 3, 4. So x is the first one. Negative x plus 3. They're trying to trick me. X plus 4. X minus 7. And what is the last row here? Exactly. You either write all of it or product or ratio, whatever you want to write. Since for once I have some room, I'm going to put the whole thing. Now, please on the side, determine the numbers or the zeros of each quantity. When is this 0? When x is? Did you find the packet? Okay. Sorry about that. And then you didn't text me and I forgot. My apologies. So this quantity is 0 when x is? This one.
0.
This quantity is 0 when x is?
3.
This quantity is 0 when x is?
-4.
Thank you. And this quantity is 0 when x is?
7.
Right. The reason why I wrote them on the side is because I need to make sure that I put them in the correct ascending order. So what is the first number that I have to put in?
-4.
Right. So -4 goes in first, then 0, then 3, and then 7. Okay. For x, it's under 0. For negative x plus 3 is under 3. For x plus 4 is under -4. For x minus 7 is under 7. And now I have to clearly identify what happens to the ratio in these 4 situations. So what happens to the ratio in those situations? So when x is -4, when x equals -4, the ratio is? The ratio is?
0.
Yes, because the top is 0. Awesome. When x is 0, the ratio is?
0.
Yes, because the top is 0. When x is 3, the ratio is? 0, because the top is 0. When x equals 7, the ratio is? Yes, because the denominator is 0. Awesome. Well done. Is that clear? Okay. So now if you remember, if you want to remember, if not, plug in numbers. If you want to remember that 1, 2, 3 will look like this, you don't have to think. You just have to copy negative to positive. I'm not teaching you not to think, but I'm just saying it will save time. Is this clear? Only this one is a linear function with a negative slope, which means it will come from positive to negative. Now on each subinterval, I only count the negatives. And notice that this is a product or a ratio. So 3 negatives, sign. Perfect. Two negatives. One negative.
Negative.
Two negatives.
Positive.
And one negative.
Negative.
Awesome. Now I'm asking myself, what do I choose? Well, I have to choose the positive because the positive is greater than or equal to 0. Is this ratio ever positive? Yes. Here and here. Which means I have to choose this particular x or these x values. So x in the interval with a bracket at -4, 0, union with a bracket at 3, but not a bracket at 7. Can anyone explain why not a bracket at 7? Because it's undefined. Very good. Well done. Is this better? Well, your problem is not going to be this, that's not going to have 4 factors. It's going to be easier. But once you understand this 4 factors, then. Next question. Anything else that you would like to go back to? Any type of problem? Any type of problem? So our test is on Thursday. Please don't miss the test, please. Next.
One, like number 4.
Yes, what does it say?
Express the given function h as a complex
Yes.
function.
Yes. So for example, let's say f of x is the absolute value of 3x minus 2. So we want an inner and we want an outer. If we want, so this was h of x, sorry. If we want to find f cum g of x, in this notation, which one, and let me show you the definition, which one is the inner? Because if I have f cum g, the inner must be denoted by, of course, it's the inner. It's the one I apply first. And the outer would be denoted by f of x.
So inner would be 3x minus 2.
Yes. So the inner will be 3x minus 2.
And outer would be the absolute value of x.
Perfect. Great job. Is this clear? Okay, next question. Anything else you would like to work on? Any type of problem? Any type of problem? Anything you can think of? Anything you can think of? Anything?
Can we do one like number 10?
Yes, what does it say?
A ball is thrown upward and outward from a height of 5 feet. The height of
Yes.
the ball, f of x in feet, can be modeled by, and it says f of x equals negative 0.1 x squared plus 0.6x plus 5.
Okay, so we can look in the book and look at a similar problem. And these are under quadratic functions. So let's take a look. Under quadratic functions. This is section 3.1. Okay. So we're given a function. This is problem 57 on page 360. We are given f of x, which is negative 0.01 x squared plus 0.7x plus 6.1. Again, the same idea. X is the horizontal distance in feet. What is the maximum height? And how far from its point of release does this occur? So can anyone give us the y-intercept of this function? How do I find the y-intercept for any function?
0.
For x, the y-intercept. 0 for x. 0, 0, 6.1. So 2, 4, 6. So I'm going to start it here. 6.1 feet. Does it have a maximum or a minimum? Very good. Maximum because the leading coefficient is negative. Very good. So we have a maximum. So we're asked to find this distance. Then we're asked to find this distance. And then we are asked to find this distance when it hits the ground. So let's start. Paul, my calculus class was from 5 to 7. But you're more than welcome to sit in this one.
Oh, no, which one is this one?
This one is college algebra.
Oh, okay, that's like no.
But I'm sorry.
All right, that's fine. Thank you.
Yeah, it was 5 to 7, Tuesdays and Thursdays.
Oh, okay.
Yes. He's from my Rundle Mills class. But he messed up the time. He missed class yesterday and he wanted to participate today, but the class was from 5 to 7. Okay, very good. So then, how do I determine the maximum height? And what do I have to determine first? How do I determine the maximum height? So what point will give us the maximum? The what? The vertex. Very good. How do I determine the vertex, the coordinates of the vertex? Awesome. Negative b over 2a. Perfect. Negative b is 0.7. 2 times a is negative 0.02. So 70 divided by 2 is 35. So this is 35. How far from where I'm standing and throwing the ball up in the air, it reaches its maximum, 35 feet. But now I want to find the maximum height. Exactly. Yes. So this value will be f of 35. So f of 35 is negative 0.01 multiplied by 35 squared plus 0.7 times 35 and plus 6.1. I grabbed my calculator. I just recharged it. So negative 0.01 multiplied by 35 squared plus 0.7 times 35 and plus 6.1. And I got 18.35. Correct me if I'm wrong. At any point in time. Feet. So 18.35. So then this height is 18.35 feet. So when we're asked to find the maximum or minimum of a quadratic function, all we have to think in is of what point again? The vertex. Perfect. Now we're also asked to find this horizontal distance. So I throw it up in the air and it will eventually hit the ground. So what do I need to determine now? How do I determine this? I have to find the x-intercept. Correct. So for the x-intercept or intercepts, I have to set y equal to 0. First, I have to write the equation. Negative 0.01 x squared plus 0.7 x plus 6.1 equals 0. I have to see it. Because if I don't, I may make a mistake in identifying the coefficients. And I know you know what I'm going to do next. It's a habit. I think it's a good habit, and you don't have to acquire it if you don't want to. What do you think I'm going to do? Divide or multiply by -1. Yes. I don't want to have to deal with a negative leading coefficient, no matter what. So then 0.01 x squared minus 0.7 x minus 6.1 equals 0. Again, this is not mandatory. I recommend this step, however. So then x equals negative b, which is 0.7, plus or minus the square root of 0.7 squared minus 4 times 0.01. Since this is a negative number, I'm going to go ahead and change this into positive and times 6.1, just because, times over 2a, just because I don't want to have too many parentheses. If I put in the graphing calculator, who knows what I'm going to come up with. So I'd rather do that. So parentheses around the top, 0.7 plus the square root, parentheses, 0.7 squared plus 0.04 times 6.1, close the parenthesis, go outside, close the parenthesis, and divide by 0.02. And press enter. I got 77.84 feet. 77.84 feet. And you can say, but there is another solution. True, but it will be behind me. It will be a negative number. Let's do it too. Second and entry. So it's behind the 7.83 or 84. Negative 7.84. Therefore, this distance is 77.84, and this one between right here. This distance is negative 7.84. But we don't care about that. Any questions? Was this what you meant? Right. Good. Anything else that you would like to go back to? Any type of problem? How is my math lab? Do you have any questions on my math lab? Anything? Any questions? Would you like me to make up some problems? Would you, or do you have everything under control?
Can we do one like number 12?
Yes, what does it say?
Use the given function simply, oh wait. It talks about the end behaviors.
So we want to graph a polynomial function or a rational function? Is that what we are asked to do? Okay, so yes, we are basically asked to graph a polynomial function. Good. So what type of function do you want? You want a even degree or an odd degree? Any preference? Okay, so let's take a look at an odd degree. Let's say Well, I made it even. What is the degree of this function? So this is 1, this is 2, and this is 3. So 3, 2, and 1. Degree. What is the maximum possible number of turns? Why do I need to know that? Because I may be tempted to make it turn many times. I can't. It cannot have more than 5. Is that okay? How do we get the degree? Okay, so this is degree 1. When I square, I get degree 2. When I cube, I get degree 3. So when I multiply degree 3 by degree 2 by degree 1, I copy the base and add 3 to 2 to 1 and get degree 6. Better? Perfect. Good. So now I'm going to find the x-intercepts, setting y equal to 0. So negative x, x minus 1 squared, x plus 4 to the third equals 0. How many solutions will I have to find? Mandatory. Exactly. 6 solutions. 6 degree 6 solutions. Very good. So can anyone give us those 6 solutions? Okay, how many times? Very good. X equals negative 4, multiplicity 3. Awesome. Yes. Very good. X equals 1, multiplicity 2. Awesome. Exactly. Multiplicity 1. Is 1 plus 2 plus 3 6? Perfect. So we can get the chart going, the table. What is the domain of this function? Right. It's a polynomial function. Remember, polynomial functions do not have asymptotes, do not have horizontal, do not have vertical. They're nice, continuous, smooth functions. I've seen it on tests. Some students in the past, not often, but it happened. I saw it once or twice. They graphed a polynomial function, and then we put in the middle some vertical asymptote. Doesn't make any sense, right? Because vertical asymptotes are characteristic to what type of function? Not polynomial, but rational. Rational functions have asymptotes, not polynomial. Is that clear? Okay, perfect. So I have to put in these values. I start with negative 4 and then 0 and then 1, 0, 0, 0. And now I have to identify what happens. What happens? What does this function do at negative 4? It has multiplicity. This particular solution has multiplicity 3. What has to happen there? Does it cross or does it turn? Before you answer, just always think in terms of the linear function. Multiplicity 1. What does multiplicity 1 do? Correct. Also think of x squared. Multiplicity 2 at 0. What does it do? That's how you remember it. If it's an odd multiplicity, it has to be a cross. If it's an even multiplicity, it has to be a turn. But of course, it depends how, right? Because in this case, there are 3 solutions there. Yes, it crosses, but not in a very nice and simple way. Slightly more sophisticated. So what will I say? It is a cross at negative 4, but what type? Not fast. Slow. Slow cross. What does it do at 0? Multiplicity 1, so it has to cross. But it's a fast cross or a regular cross. What about 1? At 1, the multiplicity is 2, so what must it do if it's an even? Yes, it is a turn. One more time. Odd multiplicity, think in terms of the linear function. Even multiplicity, think in terms of quadratic. Better? Okay. I know it's a lot. So now let's discuss the end behavior. The leading coefficient, when I multiply negative x by x squared by x to the third, it will be negative x to the sixth. So then the leading coefficient is negative. Since it's an even degree, do I think of the linear function or quadratic function? It's even degree.
Turn.
Yes. No, I'm talking about the end behavior. So it's either this way or this way, because it's an even degree. This, remember x squared. What is the coefficient of x squared, positive or negative? So it's not this, because the leading coefficient is clear? So negative infinity to negative infinity. That's all. So now let's try to make sense of what we have. So at negative 4, 0, 0, 0, and 1, 0. Let's look at the y values. I only care about the y values now. Starts at negative infinity. It crosses, but slowly at this point. It has to have a turn because it comes back and it crosses regularly, normally, at 0, 0. It must have a turn because it comes back and turns again and goes to negative infinity. These 2 points cannot be determined without a graphing calculator. So this is the function we picked. Negative x, x minus 1 squared, x plus 4 to the third. We said that it cannot have more than how many turns? Good. Let's count them. One. This is just the cross. 1, 2, 3. We don't guarantee 5 turns, but it cannot have more than 5. And this one happens to have 3. Is this better? Good. Any other type of problem that you can think of that you would like to review? Maybe finding an inverse, maybe graphing both on the coordinate system. Maybe you would like to go back to the function composition. Maybe determine the sum and difference of 2 functions and their domain. Maybe the equation of the circle, maybe the distance formula, the midpoint formula.
For this one, are we gonna have to like use a calculator?
To find the max-min, I would like that, but my math lab, I think it doesn't ask for that. So. But I would like to determine the max-min. Let's do that. So let's go to y equals. Clear if you have anything else in there. So I have negative x, in parentheses x minus 1 squared. And in parentheses x minus, oh no, it was x plus 4 to the third power. So I don't know if the standard viewing window will work. I'm going to try zoom 6. And let's see what we get. It's coming from negative infinity, crossing, oops, it goes so far. Okay, so it goes way up. It crosses normally at 0, 0. See, this is not very clear, but it's a slow cross. We're going to figure it out in a minute. And then it turns. So the calculator or the software has problems, I would say, for this function. Okay, so let's change the viewing window. So I will go to negative, let's say negative 6 to how far? Okay, 3 is good enough with a scale of 1. Y minimum, I don't really care for the Y minimum that much, not too much. -3 is good enough. But Y maximum may be up there. So I don't know. I'm going to say 100 with a scale of 20. I don't know if this is good enough. We're going to try. Okay. Still not good enough to see that maximum. Not good enough to see this. So I have to adjust again. I need the top. So Y maximum to be over 100, I'm going to make it 200 with a scale of 50. And what about the X? The Y, I would say -6 because apparently it's lower than that. And X is fine for now. This is much better. Crossing, okay. Still not good enough. I have to go lower than -6. Now, but this is very clear now. You see the difference between this cross and this cross? Because here there is only one solution, multiplicity 1, and this is multiplicity 3. So I have to adjust again. I have to adjust the minimum Y. Okay, I'm going to make it -10. Let's see now. Okay, not enough. Because I had the scale of 50, that's why. Okay, now it should work. Regular cross comes to a minimum, turns again as we knew at 1. So these two can be determined. I know that this maximum is between -4 for X and 0 for X. So I go to second and calc. A maximum is 4 between -4 and 0, and give me the maximum. Is at -1.72. And the maximum value is 150.82. And the other one is a minimum. It's between 0 and 1. So second and calculations. Minimum, which is number 3, between 0 and 1. And I don't want to guess. So it's at 0.39 and -12.3. Now I have no idea what's happening here. As you see, it just got stuck. Because normally it graphs this function here, but it's still graphing the function I graphed for the previous class. I don't know what's happening there. Okay, very good. Any questions other than what we just looked at?
Could we do one like number 13?
Yes, which was the
function-
rational function.
Yes.
Okay, yeah, let's take a look. These are problems from 3.5. Let's take a look at a function from there.
It was the one that had like the models of the pH levels.
Yes, we looked at that. So you want to look at the same type or you want to try something else? There may be some problems at the very end, I don't know, with when the review starts. Maybe, maybe not. Not really. Nope. Okay. So we want to look at a different type. We want to look at 102, or we have several questions here.
I don't think I have a specific one.
Okay, so let's take a look at this. So we're given a function, p of x is 100, quantity x minus 1 over x. Can anyone tell us what type of function this is? Very good. What type? Awesome. It's a rational function. It has x in the denominator. It has a ratio. It must be rational. Awesome. What type? 1, 2, or 3? 1. Same degree over same degree, correct? Degree 1 over degree 1. What will be the horizontal asymptote right away for this function? Horizontal asymptote. Yeah, this is not this case. It's not quadratic, and it's not linear, the odd degree. This has a horizontal asymptote. How much? Yes, 100 is the leading coefficient of the top, and 1 is the leading coefficient of the bottom. So 100 over 1, this must be 100, the horizontal asymptote. Clear? Very good. So now let's read the problem. It's about something related to smoking. See, incidence ratio of 9 means that smokers between the ages of such and such are more likely. Okay, the rational function this models the percentage of smoking-related death among all death from a disease, P of X. The percentage among all death, how much is this? How much they are smoke-related, cigarette smoking-related diseases, death. So P of X, in terms of the disease's incidence ratio X. The graph of the rational function is shown. Use this function to solve exercises 103 through 106. 103. Find P of 10. 10 minus 1 is 9 over 10. I can plug it in and determine that. So let's find that. P of 10 first. So the problem is, the problems we're looking at are 103 through 106, page 429. The function is P of X, 100, X minus 1 divided by X. And we're asked to find P of 9. Fine. 100 multiplied by 9 minus 1 divided by, P of 10, I'm sorry. They want 10. Divided by 10. I will simplify because I'm simplifying factors. 10 minus 1 is 9. 9 times 10 is 90%. So if the ratio X, which is the disease's incidence ratio X, if that is 10, among all deaths, 90% of them appear to be smoking-related diseases. Okay. Find P of 9. Round to the nearest percent. Describe what this means in terms of the incidence ratio 9 given in the table. So the incident 10, the incident ratio, so we were asked to find P of 10. So when X is 10, we're talking about people ages 55 through 64. And apparently they do have, in this table, they suffer of lung cancer. Okay, so P of 9 will be the exact same idea. What is the horizontal asymptote of the graph? You already told me. Y equals 100% or 100 is the horizontal asymptote. According to the model and its graph, is there a disease for which all deaths are caused by smoking? The answer is no, because this function will never ever touch 100%. So even if the incidence ratio of a certain disease is going as far out as to infinity, if you want, still this we can never say for sure that it will touch 100%. So we can't say that. Okay, any other question? Is this what you had in mind, just to look at a rational function, find a horizontal asymptote? Okay. Anything else that you would like to go back to? Let's go through the topics one more time. So section 2.6, and you'll tell me where do I stop. In section 2.6, we looked at function composition and some sum and difference product ratio of functions, and decomposing a function that we just looked at. So do we need an example of two functions and finding the sum, difference, product, ratio, common domain, domain of the ratio? What about function composition? Finding f comp g and g comp f. Are we okay with that? Do we need another example of any of those? It's okay if you say yes and we'll make one up or find one. Are we okay? Is that good? Okay. That is 2.6. In 2.7 is finding the inverse function. Finding the inverse function and graphing the function and the inverse on the same coordinate system. Do we need something similar? Yes? Very good. So let's choose a function. Any preference for the function? Rational? Okay, rational, in order to find the inverse is not going to be difficult, but graphing both on the same coordinate system will be a little bit of an issue. A little bit. So let's find a function and find its inverse. And then we'll work on another example in which both can be graphed easily on the same coordinate system. Okay, but for now, let's find the inverse of a rational function. Very good point. So 2x plus 1 divided by x minus 3. What type of function is this? Good. And now the question is, how do I find its inverse? And there is a 4-step procedure. And this will be the same for any function, right? But it depends on the function what you need to do then. So the first step is replace f of x by y. Second step is, very good. Awesome. And now please remember that we've done this a long time ago in chapter 1. And here's my hint for you. What do I mean by that? Exactly. So remember to distribute, or first write it as x y minus 3 and equals 2y plus 1. So that's the first step. What am I solving for? Y, indeed. Very good. I am solving for y. So xy minus 3x equals 2y plus 1. Next step. Remember, I'm solving for y. Next step. I can't, but first of all, I have to put the terms that should be on the same side together, right? So I have xy minus 2y equals 3x plus 1. So now the next step would be to combine like terms, but I can't, so there must be another way. And the other way is, say it again. I think I heard it. It's correct, unless it's in my head, or is my wishful thinking? What was it? I want to solve for y, but I cannot combine these. So what is the other option? The only other option? By factoring out y. Right? Right? That's the only way. If I cannot combine them, I have to factor out y and get x minus 2 and 3x plus 1. And then obviously y would be, what do we need to do to both sides to get y? By? Very good. And of course, I have to write that x cannot be equal to, and this is our f inverse. You may encounter something like this in my math lab. But now let's look at a function that we can find the inverse for and graph both on the same coordinate system. Let's look at a radical function. Let's say f of x equals the square root of x plus 7. Can anyone give us the domain of this function and the range of this function? Think in terms of transformations. Picture the square root of x. Then picture where this is going, and you will be able to find the domain very easily. Or just tell me what to write on the side, and I'll solve it, and we'll find the domain. The square root exists when it's applied to what type of numbers? Not only. Do we picture the square root of x? We remember the graph from transformations of the square root of x? Right? Where will this go?
Over, is it negative?
Yes. So what is its domain then?
So negative.
7.
7 to
Exactly. You either remember that or you write x plus 7 must be a number greater than or equal to 0, otherwise I cannot take the square root from it. One or the other. So then x greater than or equal to negative 7, so this is the domain. Exactly what you said with the transformation. Same thing. One or the other. Good. Now picture the graph and please tell me the range. What is the range of this function? Correct? 2? Of course. I don't have the inverse function, but I would like you to give me the domain and the range for the inverse function. I haven't even determined it yet. What will you say?
negative infinity to 7.
Careful. The domain. Okay, remember this. Remember what's happening with the inverse function. We go from Earth to the moon. What does the inverse function do? So if this is the domain of the inverse of the function, this is the range of the function. What will this become for the inverse function? And this will become? Good. So what will you say then? Of course. And the domain and the range will be? Of course. Imagine always that this is the situation with the inverse function. So if the function takes us from Earth to the moon, the inverse function will be defined on the moon, bringing us back to Earth. Awesome. So now let's find the inverse. First step, like before, I have to write that y is the square root of x plus 7. But now this is a different type of equation. It's not rational. It's not quadratic. It's not linear. It's not the absolute value. What is it? Once you read it, you will say, it's a radical equation. How do I solve a radical equation? What do I have to do?
You square.
Exactly. I square this side and I square this side. So this is y squared equals x plus 7. I'm sorry, I omitted the intermediate step. Forgive me. So first I have to write that x equals the square root of y plus 7. So then this is y, and this is x squared. Sorry about that. I can reverse it afterwards, but it's good to stick with what we decided. So first we write y instead of f. Secondly, we swap the two, and then we solve for y. And we square both sides, and we get x squared equals y plus 7. So therefore, y will equal x squared Very good. So this is our F inverse, x squared minus 7. But remember one thing. This is x squared. How do I graph x squared minus 7? Down 7. But is this 1 to 1? No. That's why the domain is 0 to infinity. Is this now 1 to 1? So that's why this is so important to determine. You can say, what about this? Why is the domain 0 to infinity? Because this function is polynomial, quadratic, is defined everywhere. True. But it will not have, this whole function will not have an inverse. This one does. Good. So this was in section 2.7. In section 2.8, we had the distance, the midpoint, and the circle, the equation of the circle. Any questions on the distance, midpoint, the equation of the circle? Do we need any example? No? Okay, in 3.1, we looked at quadratic functions. We had an example with the max min, with the vertex. Do we need to graph another quadratic function? Showing the shape, the vertex, the x and y intercepts, the y-intercept. Okay, perfect. So let's do that. Would you like to choose a quadratic function, or you want me to choose a quadratic function? Okay. So let's say f of x equals negative x squared minus 4x minus 4. Is this quadratic? Is this quadratic? Yes, it is. It's a quadratic function. So we have to go through several steps. And the first question will ask you to find the shape. How do I know the shape? How do I know whether this is a max or a min? Because the leading coefficient is negative. Remember x squared and remember negative x squared. So since it's a negative leading coefficient, this is it. It's a max because a is negative 1. In step 2 or B, I need to determine the vertex. How do I find the vertex? We had a situation today with that word problem with the ball thrown. Yes, I have to find negative b over 2a, and b is negative 4 over 2 times a, which is negative 2. Always keep in mind these are 3 negatives. And we know that. What happens with 3 negatives? Yes, so the answer is negative 2. How do I find the y-coordinate of the vertex? How do I find this? Very good. Indeed, f of negative 2. Be very careful how you plug it in. Oops. Because remember, you have to use parentheses, especially when the number is negative. By the order of operations, I have to square negative 2 first. When I square negative 2, I get, with minus in front, very good, negative 4 times negative 2, positive 8, and minus 4, and I get, very good. C, X-intercepts. Can you already picture this graph? Where is the vertex? At negative 2, 0, and it has a maximum. Are there any other x-intercepts? The function turns on the x-axis. So there are no more x-intercepts. This is it. So if I want to say x-intercepts, I will say yes, x equals -2, x equals -2. Obviously, this must be a perfect. Y-intercept. That's D. Y-intercept. When x is 0, so I have to find f of 0. 0, 0, -4. So 0, -4. As you remember, E and F are just words, and G are just words. G is the range. Since we already pictured the graph, although we didn't even graph it, what is the range of this function? -infinity to right? Because it touches the x-axis at -2, 0, so it must be -infinity to 0. What is the axis of symmetry? The axis of symmetry is the vertical line going through the vertex. Exactly. X equals -2. What is the maximum, since it has a maximum? What is the maximum value of this function? We already know the range, so we know the maximum. How much? Exactly. Max value is 0. Well done. So now we are ready to graph this function. At -2, 0 is the vertex. Here's the axis of symmetry. X equals -2. I have one point, 0, -4. I have this side, and I'm going to try to find a point on the other side that is symmetric with this one, so I can keep the graph as symmetric as possible. So this is the graph of f of x equals -x squared minus 4x minus 4. Oops, I didn't mean that. Any questions? So these are the steps that we use to graph a quadratic function, to go through when we graph a quadratic function. So this was section 3.1 plus the applications that we already talked about.